2.1 is the rectangular coordinate system. Are we familiar with this? Rectangular coordinate system. When we use this is when we have two variables, x variable and a y variable. Before we only had an x variable, we only had one axis, one x-axis, right? But we were solving inequalities like one's x less than 2, and we were saying let's shade to the left of 2. But now if we have two independent variables, x and y, x can be any real number. I can go forever to the left, forever to the right, and y could be a number. I could go forever up or forever down. What do solutions look like if I have two variables? I have two answers, an x and a y. We call that an ordered pair. Are you all familiar with how to graph points like -1, 4? That's a prerequisite. If you tested in this class, presumably you know how to do that. I go, what direction, left or right? Yeah, left 1, right? Left 1 is here. I'm along this line somewhere. And along this line, I should go where? This +4 means up 4, right? Okay, that corresponds to this point here, -1, 4. These are called ordered pairs. And we get to the first thing of the day. How do you find the distance between any two ordered pairs? If I have two ordered pairs, let's call them A and B. The distance between A and B would be the length of this line. Are we okay with that? Okay, this line, it turns out if we go straight down from B and we go straight down from A, we have a change in x distance. How do you find the distance between two numbers? All right, what's the distance between 3 and 9? 6. How did you get 6? Subtracted? Wait, but if I do 3 minus 9, I get -6. How do I make sure distance is always positive? Take the absolute value. Likewise, I take the x values, x1, x2, I subtract them and take the absolute value. Does that always work between the distance of any two numbers? Let's try -3 or -2 and 11. What's the distance between them? If we subtract and take the absolute value, does it work? All right, here's 0, 5, 10, 11. Here's -2. The distance between them would be 2 plus 11 is 13. What's -2 minus 11? -13. Absolute value is 13. This works for any two numbers. You subtract them, take the absolute value, find the distance between them. Okay, anytime you see this absolute value thing, you should think that's the distance between two numbers, the x values of the ordered pairs. How do I find the change in height? I subtract the y values, and I take the absolute value. Now I have a length of this vertical side. I have the length of this bottom side, and it creates a right triangle. What's the equation relating the sides of a right triangle? Yes, Pythagorean theorem says side A squared plus B squared is equal to C squared. Yes.
Can I get this?
You can do it at the end. Yeah. Okay, so what is A squared plus B squared is equal to C squared? In this case, length, this can be in either order. I'm just going to write, maybe I'll relabel these side A and side B. A would be what? The absolute value of x2 minus x1 squared plus side B would be the absolute value of y2 minus y1, absolute value squared, is equal to c squared, but that's actually the distance between them. That's what we're trying to find. I'll call this distance d squared. Any questions about that? Do you recall that if you square a negative number, it becomes positive? Square a positive number stays positive. The absolute value squared is redundant. I don't need to take the absolute value. I could just write it as x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. If I solve for the distance, I would do what? Take the square root of both sides. If I take the square root of a perfect square, what kind of weird magic happens? I should get two solutions, right? I should get plus or minus. But because we're talking about a distance, we're saying a positive number only. I'm going to throw out the negative answer. And I only want the positive root. We're going to memorize this formula so we can apply it more quickly. Next thing we have is called the midpoint formula. If I want to find the midpoint between any 2 points, I draw the line and I get this value. It turns out you can average the x values. How do you average two values? Add them together and divide by the number of values 2. We average the y values. We get an average of the horizontal distance would be here. The average of the vertical distance would be here. And we end up with this midpoint. Let's try applying both these new formulas to find the distance between -5, 8 and -10, 14. So let's apply this distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We just need to label these points. Let's call this x1, y1, and x2, y2. If we plug in, we get the square root of what minus what? All right, -10 is x2 minus x1 is -5. I put parentheses around the -5. I don't have double operator, minus -5. You can't have operators right next to each other. We need to separate them with parentheses. Next, we have y2 is 14 minus y1 is 8. Any questions about this? It's just a matter of simplifying. Could I have labeled the order pairs opposite? Yes, I could have made the first one x2, y2, second one x1, y1. And the formula would provide the same answer. Do you believe me?
Yeah.
In math, you don't have to believe me, right? You can just try it out. See if you get the same answer. Is equal to square root of what squared? -10 plus 5. -5 squared plus 14 minus 8. 6 squared. Square root of 25 plus 36. 61. Can we reduce that? I think that's prime, isn't it? All right, let's leave that as is. Let's find the midpoint between those two values. Well, let's average the x values. -5 plus -10. I put the -10 parentheses to separate the plus and minus operators. Then we have 8 plus 14. And we divide them each by 2. We get -15 halves and what is that? I'm asking because I'm feeling a little slow today. -15 halves is comma 11 is our midpoint. Any questions about applying either of these formulas? All right, this first equation, y equals 3x minus 5. Do you guys know how to graph that? Yes? How many solutions does it have? Infinite? Can you tell me one of them? If there's infinite, give me at least one. What's one solution? I heard 0. Okay, if I plug in x is 0, then I get y is -5. So the solution has an x value and a y value. an ordered pair. That is one solution. You said there's infinite. Can you give me another? What? Okay, if I plug in what for x? Oh, you plugged in 0 for y? If y is 0, then you get 5/3 for x. So you see we can plug in any number for x, we get a different number for y. That's why there's infinite solutions. But it turns out that's not too helpful. It's nice to see some sort of pattern of solutions. And that's the whole reason we graph. We graph to represent infinitely many solutions and the pattern that they make. Does this idea make sense? We graph and we have a y-intercept, a 1, 2, 3, 4, 5, and a slope of 3, decently steep. I'm not being excessively accurate right now, but this is the graph, and we know the relation between solutions. What does that mean? I can pick an arbitrary point on the line, and that's a solution as an ordered pair. That's called a linear equation. Why do we call that linear? The exponent of the x and the y are both 1. We don't have square roots. We don't have squares or cubes. We don't have division with a variable on the denominator. This next equation, would you say it's linear or nonlinear? Even though the exponent's 1, if the variable's on denominator, it's a nonlinear relationship, which means these have curvy lines. How many solutions does this have? You can do the same thing we just did. How do you find a solution? You plug in. What's the easiest number to plug in for x? 0, 1/2. I could plug in anything for x and get a value. Right? I could plug in anything for x. Maybe I'll say c, and I get 1 over c plus 2 for the y value. That's why we have infinite solutions. That doesn't help you too much. We like to graph to see how they relate to each other. In the future, we'll learn how to graph this. Not today. This is a special graph with a vertical and horizontal asymptote. And we get this nice curve over here and this nice curve over here. Anyone know how to graph x squared plus y squared equals 25? If the y was not squared, it would be a parabola. But if they're both squared, we're going to go over how to graph this today. They're both squared. It's a circle with radius 5. That's as good as I can do for a circle. Any questions about this? Let's practice graphing. I'm going to pretend like you don't know how to graph these functions. And if you don't know how to graph them, we just plug in values. And this is what your calculator does. Calculator is very dumb, doesn't know how to graph things. It picks an x value, finds the y value, plots a point. But they're very fast. It can do so many of these points fast that it looks like a line. We're not fast. We'll just do 5 points and connect the dots. Okay, graph these. An absolute value, linear absolute value has a V shape. The important thing is to find where the inside of the absolute value is 0. That's the most important point. It's going to tell us where our peak is. If I have an absolute value, if I have a square, I'd also like to know where is that 0. I'm saying the whole inside. If I have an absolute value, I'd like to know where that's 0. And a square, I'd like to know where that's 0. And we want to plug in values around those. If we have x values and y values, where is x minus 3 equal to 0? When x is equal to what? 3. What I'm saying is I'd like to plug in values around 3. For instance, 2, 4, and 1, 5. 2 points on each side. Any questions about that? Turns out you don't. Because when it's 0, if I pick points around it, I will get negatives inside the absolute value. I am going to get negatives. Now, if this is not enough points for you to connect the dots and make a pattern, plug in more points. You don't have to do only 5. Let's start with 3. If I plug in 3, what do I get? -2, absolute value of 3 minus 3 is what? Absolute value of 0 times -2 is 0. Very good. If I plug in 2, what do I get? Absolute value of -1 is 1 times -2 is -2. If I plug in 1, what do I get? Very good, -4. I found out where it was 0 on the inside because that gave me negatives. Right. When I plugged in 1 and 2. If I plug in 4, what do I get? -2. If I plug in 5, what do I get? -4 again. Wow, there's some sort of symmetry going on. In the future, we'll definitely investigate that. But for now, we're just going to plug in points. You know what? I drew this without thinking. I should redraw this. I'm sorry for using pen. I should look at the range of x values between 1 and 5. That means I'm plotting points over here, right? Presumably, I should do something more like this, to have more space on the right. Then if I look at my range of y values, they're negatives. That means they're going to be down here. Presumably, I should draw my axes more like this to give me space where I need it. Now I'm going to plot these points. On the x-axis, I need 1 through 5. 1, 2, 3, 4, 5. On the y-axis, I need 0 through -4. -1, -2, -3, -4. And we plot the points. 3, 0 is here. Why does that disappear? 3, 0. I don't know. 2, -2. 1, -4. 4, -2. 5, -4. Can we connect the dots in a manner that makes sense? Should I have a curved top or a peak at the top? A peak. And you only really know this from experience of graphing linear absolute values, that they should be straight lines on each side. And I draw the arrow. The arrow means it continues forever in that direction. Remind me again, why did I graph this? Why do I graph anything? It gives me every possible solution with every x and y value that make the original equation true. Any questions about that? All right, for the sake of time, I'm going to skip these 2 examples. They'll be done in a similar manner. And I'll go to this one, which is slightly more tricky. I'll just say different, not more tricky, slightly different. I have x and y values. And in this case, y has the complicated thing happening to it. Previously, we had an absolute value of an x. Now we have a square of a y. That means we want to plug in values for y instead of x. And that's why this is different. Okay, what would that make that 0? Y equals 0. I want to plug in values near, y equals 0. What are values near 0? -1, -2, and 1 and 2. It would make the x 0. Yeah. Now that we have those y values, we'll plug in to find the x values. What is 0 squared minus 4 equal to? -4. What is -1 squared minus 4 equal to? -1 times -1 is +1 minus 4, -3. What's -2 squared minus 4? Yeah, -2 times -2 is +4 minus 4 is 0. And why do I know that these are -3 and 0? I'm squaring the positive numbers instead of the negative numbers. I'll get the same result, but 1 squared minus 4 is -3. 2 squared minus 4 is 0. If that's not enough points for you to see what's going on, you graph more points. So draw my axes. My x values are from 0 to -4. That means my y-axis should be drawn to the right. And my y values should be in balance, equally high and low. I'm going to draw my axes in this manner. My x values I'll label from -4 to 0, -1, -2, -3, -4. My y values, -2 to 2. You really want to take your time, make sure these are equally spaced. I'm not great at that. Otherwise, your graph looks a little wonky. Bless you. -4, 0 is my first point. That is the most important point. Where'd it go? Okay, let's plug in -3, -1, 0. These should be 0, -2. Oh, is here. Why does that keep disappearing? And then I have the points -3, +1, and the points 0, 2. Do you know how to connect those dots? If one of them squared is a parabola, because we have only the y squared, not the x squared, it's parabolic in shape. It's like a sideways U. And we draw arrows to denote that this goes forever to the right. The same pattern. Any questions about this? Okay, would this one have straight lines or curved lines? Straight, because the exponent of the x is 1, and this would be a v. Would this one have straight lines or curvy lines? Yeah, the x squared, that's going to be a parabola. All right, next thing, find x and y intercepts along the x and y axis. The x-intercept is where my graph would cross the x-axis. What do you know about those y values? The y value is always 0 at the x-intercept. And that's how we'll solve for those. You plug in y equals 0, because that's the height. Anywhere along the x-axis, the height is 0. Let's practice solving this first problem. What is the x-intercept of this function? We're going to plug in y is equal to 0. 0 is equal to x squared minus 2x minus 3. How do I solve this? Factoring. I get x minus 3, x plus 1. Does that work? X minus 3 is equal to 0, which means x is equal to 3, or x plus 1 equals 0. We subtract 1 from both sides, x is equal to -1. I have two x-intercepts, but they occur on the xy plane. My intercepts are what? 3, 0, and -1, 0. The most common mistake would be writing 3, -1. In a similar manner, we can find the y-intercept because any point on the y-axis has an x value of 0. It has the same horizontal positioning right in the middle at 0. To find the y-intercept, we plug in x is equal to 0. Usually a little bit easier. Y is equal to 0 squared minus 2 times 0 minus 3. Y is equal to what? -3, and this corresponds to which ordered pair? We plugged in x is 0, and y is -3. Can you? In this form, these will always be 0, right? All right, any questions about that? Once again, I'm going to skip the ones that are more straightforward, and I'm going to move on to the more tricky problems that you'd encounter in the homework, which would be these two. Okay, let's start off with the y-intercept. How do I find them? 0 for x, right? If I plug in x is 0, what do I get? I get -4 squared is what? +16 plus y minus 4 squared How would you solve this for y? Yeah, subtract the 16. Y minus 4 squared is equal to negative 12. And then what? Take the square root. Yes. We undo the square to take the square root. You notice what happens? Plus or minus. This is I root 4 times 3. 2I root 3. And then I add 4 to both sides. I'm gonna stop there though. These are imaginary non-real solutions. On my graph, what that corresponds to is there's no intercept. My graph doesn't cross the y-axis. No y-intercept. Any questions about that? Because on my axis are only real numbers, not complex numbers. Likewise, we solve for the x-intercepts. Yeah, it's exactly the same, right? Y is equal to 0. And we would this time have x minus 4 squared plus, when we plug in the 0, we would get 16. And yeah, when is x minus 4 squared equal to negative 12? For no real number of x, no x-intercept. And we're going to learn how to graph that. That circle will be off in one of the quadrants, not touching either axis. We'll graph that by the end of the day. All right, what about x squared plus y squared is equal to 4? How do we find the x-intercepts? We solve x squared plus what squared? 0 squared. I get x squared is equal to 4. X is equal to plus or minus 2. Corresponds to what intercept? Negative 2, 0, positive 2, 0. And the y-intercept, exactly same thing. 0 squared plus y squared is equal to 4. Y is equal to plus or minus 2. 0, negative 2, comma, 0, 2. One circle crossed each axis twice. Another circle didn't cross either axis. Just to visualize, one circle looks like this. Another circle looks like this. Any questions about this? All right, this is a note just to talk about how calculators graph by plotting points and how that can be problematic. I'm not going to test you on this. We don't have time for it. I'm going to move on to section 2.2, circles. A circle is a set of all ordered pairs who have the same distance from a single point, called the center. The radius is the distance between the center and the edge of the circle. You now have the tools to derive the equation of a circle, centered anywhere. Because we can say the center is given by an arbitrary ordered pair HK, and we can say that the points on the circle are x and y. How do I find the radius of a circle? It would be this distance. How do you find the distance between 2 points? The distance formula, which is what? R is equal to, or the distance is equal to square root of x minus h, x2 minus x1, x2, y2, x1, y1. X minus h squared plus y minus k squared. Are we all comfortable with this? Square root. Our formula will just square both sides. R squared is equal to x minus h squared plus y minus k squared. If we can put our equation in standard form, we can find the radius and the center. Let's practice using this. Here's an equation in standard form. Can anyone tell me the radius? R squared is equal to 25. The radius is 5. The square root of it, right? Where is it centered? I'm subtracting 4 And if I have plus 3, what am I subtracting? Negative 3. What's the opposite sign of the number? Are there any questions about that? It's a little bit tricky. The plus 3 becomes a minus negative 3. It's centered at 4, negative 3. All right, this one, what is the radius? If it's equal to 12. Very good. It's square root of 12 squared, which we can simplify to square root of 4 times 3 is 2 root 3. Where is this centered? If I have x squared, it really means x minus 0, y minus 1/2. We're centered at 0, 1/2. Any questions about this? X squared plus y squared is equal to 7 is centered where? Yeah, we're subtracting 0, 0, 0. And the radius, if it's equal to 7, would be just the square root of 7. Any questions about this? Find the equation of a circle with, this doesn't make sense, right? Centered at 1, 3, that passes through 4, negative 1. Then graph the circle. Do we know for the equation of a circle, x minus h squared plus y minus k squared is equal to r squared? Do we know h, k, or r? hk is the ordered pair where it's centered. Presumably h should be 1, and k should be 3. X minus 1 squared plus y minus 3 squared is equal to r squared. It remains to find the radius. Then I have the equation of the circle. How can I find the radius? Yeah, the 4, negative 1. Where do we plug it into? X and y. This is x value, the y value. Very good. 4, negative 1. Then we solve for r. 4 minus 1 gives us 3 squared. Then we have negative 4 squared. 9 plus 16. 25. And r is equal to? Very good. We square root both sides to get r is equal to, technically plus or minus 5. We'll just take the plus 5. Radius is referring to distance. The question was asking for the equation of the circle, x minus 1 squared plus y minus 3 squared is equal to, I'll just write it as 5 squared. You can write 25, and that's correct also. Any questions about this? I'll do the second example last, because the last one is the hardest. I want to make sure to get to that. Actually, let me change this to a slightly more difficult problem that shows up on the homework. 2x squared plus 2y squared plus 28x plus 24y plus 114 is equal to 0. How can I put this in the form of x minus h squared plus y minus k squared is equal to r squared? It turns out there's a tool that you learned in a few sections ago that teaches you how to make perfect squares. What is that tool called? Yes, completing the square is correct. We want to complete the square. The first thing I'm going to do is I'm going to group the x terms together. 2x squared plus 28x. And then I'm going to group the y terms together, plus 2y squared plus 24y. And then I'm going to write the number on the other side. I'm going to subtract 114 from both sides. Okay, I'm going to make a very common mistake. Tell me what I did wrong. What's 14 squared? 14 times 14. Does anyone have a calculator? 196? What did I do wrong? I didn't factor out the 2. This will, in fact, be wrong and not be a perfect square. This formula only works if the leading term is 1. Okay, let's factor out the 2. X squared plus 14x. I'll factor out the 2 here also. Y squared plus 12y. Okay. If I take half of 14, what do I get? And if I square it, I get what? I made a mistake. What mistake did I make? I made another mistake. What other mistake did I make? I actually added 49 to this side, but I didn't add 49 to this side. I added 2 times 49 to this side. Because if I distributed this 2, does that make sense? Okay. It turns out for this problem, it's going to be easier if we just divide both sides by 2 before we actually start adding these numbers to both sides. If we divide both sides by 2, instead of factoring out the 2, life's a little bit easier for us. And 114 divided by 2 would be, is that 57? Then I can add 49 to both sides without worrying about it. And I can add 36 to both sides without worrying about it. What does the first perfect square factor into? X? Yes. The 14 divided by 2 was 7. Oh, close. Yeah, y. Y plus 6 is equal to, what is that when we add it together? It's 28. Why do I feel like I messed up? Okay, can I get someone to second that? It's 28, right? 70, 85. 85 minus 57. Yes. All right, thank you. Where is my circle centered? Centered at -7, comma, -6. You take the opposite sign. And what is the radius? Close. 20, yeah, 28 is equal to r squared. 28 would be what? 4 times something? Okay, yeah. 2 root 7. All right, I want to at least talk you through the other example we skipped, so you know how to do this homework problem. Write the standard form of an equation of the circle with endpoints of diameter -1, 0, and 3, 4. I'm going to graph these. You don't have to, but it might be nice to visualize what's going on here. -1, 0 is here, and 3, 4 is here. This is the diameter of the circle. Can I draw the circle? Something like that, right? What 2 pieces of information do I need for my equation? I need first the center. Any ideas how we could find the center of the circle? Midpoint formula. So you just take the midpoint of those 2 values, which would be pretty easy, right? H is equal to 3 plus -1 over 2. 1. And K would be the midpoint 0 plus 4 over 2, which is 2. How do you find the radius? The distance formula between the midpoint and either point. Maybe I just do these 2. Distance formula. We're out of time. Good luck with your homework. I'll see you tomorrow.